So what's the hardest part of deploying AI in physical environments?
Have you ever been to a parking lot lately? It's a dark, dingy place with not the best lighting and not the best connectivity. Stringing these systems together is really, really tough.
What pulled you into AI engineering in the first place?
Things are changing very constantly, and I think that's both a good thing and a challenging thing.
Do you remember the first time your model actually worked?
Yeah, I mean, the first time that I remember I interacted with LLMs in general, it felt like magic, right? But yeah, I also do remember when things just wouldn't work because it's so non-deterministic is more frustrating because there's no set ways to do it.
What's the next skill every AI engineers need to learn right now? More math, or better prompting, or better storytelling even?
Better storytelling, definitely. You know, there's always talks about prompt engineering. I think context is one of the most important things using LLMs. That's how an agent knows, a model knows what you're talking about, what tools it needs, what resources it needs. So by providing the right context, the right story, the model will behave more closely to what you want it to do.
What is the hardest bug you've hit working with large language models?
I don't know if I would say this is a bug, but it's more of a problem in the sense that the tokens end up being a huge problem. So if you have a
Token limit?
Yeah, and in particular working with tools. So if you've heard MCP, this term is used a lot. An AI accessing MCP tools often can consume an incredible amount of tokens. And I don't really think that is necessarily the best way. So it's like even accessing, like I was trying to get Claude to access my Notion, and it's like reading a single page was like 50,000 tokens. And it just like doesn't really scale to like do a larger task.
Do you fix the problem?
I did fix the problem. So the solution actually was, instead of having the AI interface with Notion directly, I had it write a Python script. The AI wrote a Python script to talk to to Notion and then get the data it needed, just the data it needed. So it's like very few tokens.
What's the next skill every AI engineer needs to learn?
Maybe controversial, but I do think you need to learn how to code.
Wait, are there people who doesn't know how to code?
Yeah, I mean, if a lot of these low-code tools like no code.
Oh, like people who just use prompting or storytelling.
Yeah, don't short-circuit your own understanding of how these things work.
What's the hardest part about translating natural language into SQL that actually runs?
Text-to-SQL is like a very long-standing, very difficult problem. Lots of labs out there have tried to solve, and doing it in one shot is extremely difficult. The cheat code that we have is we have a SQL execution engine, which is the Jupyter Notebook. And so the model has multiple tries to get the right answer. I think I haven't seen the numbers, but I bet you if you went and you looked, I would say that the model gets the first SQL try probably wrong a lot more often than you would expect. But the nice thing is with agents, we can say, hey, this is the error, this column doesn't exist, or like, this return no data, this doesn't seem right, and give the model another shot over and over again until it gets the right answer.
What's worse, a hallucinated number or confident analyst?
Definitely, I have to say, hallucinated number is pretty tough. Hallucinated numbers are actually like one of the backbones of one of the biggest issues we just solved. Most of our internal structure relies on UUIDs to identify the different cells. And it turns out models are freaking terrible at identifying UUIDs. They will very, very regularly flip one or two characters in the UUID, which obviously makes it the wrong UUID. And so we did a huge effort internally to make sure that the model never has to see a UUID. We replace it at runtime with what we call a short ref, which is like something that's much easier for the model to handle.
What is the hardest bug you've hit working with large language models?
Well, I'll say probably recently when I was working with MCP servers, not just using them, but also developing them. They just don't work as expected, again, due to the non-deterministic attribute. You sometimes expect a tool to be called a certain way, but it doesn't do that, and you have to tweak the prompts, the tool description, the tool names, the implementation, everything, and it's different from your typical software development cycle.
How is it different?
Well, how I see it is in the non-AI space, software engineering is like 1+1 is equal to 2. But with AI, it's 1+1, it could be 3 sometimes. Yeah.
That does not make sense. How?
It just, you don't get a set result that you're always expecting every time.
Okay. Would you rather babysit your API calls manually at 2 a.m.?
I'm sure nobody would want to do that, which is why, uptime guarantees are nice.
Have you ever done that before?
Yeah. It's very stressful in the moment. It feels like it lasts way longer than it actually does.
How does computer vision power Metropolis smart parking system?
We have a recognition engine that's been developed over the past 7 years, and it's been trained on millions and millions of car entrances and exits. So we can recognize not just the license plate, but the car itself. So like if you put a bike rack on your car, or you change the bumper sticker or something like that, we still know who you are. So it's the biggest thing is that it's been homegrown and developed over a long period of time.
So let me ask you a dumb question. So what happens when a pigeon decides to photobomb your model?
Just the photo model.
Yeah.
We can handle that pretty well because again, we're not just we're not just taking an image. It's actual, the moving image of the vehicle. So we're doing continuous recognition. So the pigeon will fly in and fly out, but we'll still recognize what's there.
So what's the hardest part of deploying AI in physical environments?
You might think that wireless is the answer, but in many cases, you actually have to put wires in place to do it. In fact, one of the most expensive parts of an installation like this is the wires. The cameras, not so expensive, but the wires, very expensive.
And also, if the wire breaks, someone needs to go there and fix it and replace it. That's expensive.
Yeah.
Do some people have to debug at 2 a.m.?
Sometimes.
In a parking lot, in the dark,
Parking lot,
in the cold. How do you ensure privacy when dealing with license plates and people's movement data?
There's definitely, laws and regulations that we actually do have to adhere to. And it's, that, and also just even we're handling financial matters. So again, we have to be very careful about how we handle that, people's payment details. So yeah, we actually do have a lot of different guardrails and safeguards, and we have a data classification system that allows us to keep track of all of that. We actually audit our systems to make sure that they're functioning correctly and that we're handling data properly. One thing I'm actually really proud of is that our engineers actually 2 days a year actually go out to the field and actually see this stuff in action. So even if you're just working on payments, if you're working on finance, or you're working on some other aspects, or like the notification system, you're going to go into one of our lots and see how it actually functions, because we're dealing with a messy real world, and if our systems aren't able to handle all the different cases, then the system is broken for the customer. So being able to understand that in a more holistic way by actually seeing it in person is actually been a really great help for us.
OpenRouter system connects to over 100 different models. What's your take on that scale?
I think we might be at 400 plus actually.
Really?
Yeah.
400?
In general, we want to be the provider for every model that exists, just to give the users the most variety of choice. And for every model, we want every provider to give the users the best uptime.
How many models do you think you could handle before your brain rate limits?
I don't know. I use like 3 models on a daily basis, maybe.
If your model ran slower but cheaper, would your clients call it innovation or budget cutting?
Probably budget cutting.
Yeah? Will they love it?
Probably not. I think like as an end user, you want something that's fast and it works and it's cheap. You really don't want to compromise on any of those.
How do you manage updates to thousands of deployed models in the field?
Okay. Well, we have a whole operations team that handles that.
Like rollout?
Rollouts, yeah. So, I mean, it's a standard type of thing. We have to be very careful. We don't want to break anything. So we have continuous feedback loops that monitor the performance of those models. And then we slowly deploy them over time. And then, we have some customers that are, perhaps a little more risk averse, and then some that are maybe willing to take on more updates. For example, like, if it's a site where we are the owner operator, we're definitely, we'll be able to take it on because we'll get very rapid feedback.
Right.
But I don't want to, disrupt an entire airport, which is one of the things that can happen if we don't do it right.
What's the wildest project you ever seen someone build with AI recently?
I don't know if I would describe it as wild, but there is one project that I'm working on at my job. So I'm working with a bunch of data scientists and doctors, mostly radiologists.
Oh wow.
Yeah, one of the projects that I'm working on surrounds maternal fetal medicine using ultrasound MRIs. So basically, we want to analyze 11-week prenatal old fetuses for their brains to make sure that they may not have any abnormalities in the future. Some abnormalities that I could think of off the top of my head are an arachnoid cyst and a Danny Walker malformation. They're both basically considered like tumors inside of a baby's brain, which could develop in the future. So using AI to help detect that and then help prevent that. It's one of the hardest projects that I've done, and it has its challenges too, because like sometimes the MRI images can appear to be obscure. So the AI model may not be as accurate to pick up certain abnormalities.
If you have a wife, would you actually use it or just tell your friends you saw it?
No. If I had a wife, I would use it.
If you have a wife, you will actually use it.
Yes.
But why do they love AI?
No. Some of the doctors, majority of the doctors that I have met with, they're not really a fan of AI because they don't know if they can trust it to help with their treatment, prevention for patients. But
They want 100% accuracy.
They do, but that's not always possible.
Yeah.
There's always going to be some sort of discrepancy or, mistaking the data too, because sometimes the data could be misleading too, which is why it's important to do your pre-processing correctly.
How do you think AI will change the role of data analysts in the next few years? Do they become supervisors for models instead of query writers?
I think that's a really good question. I don't know, but I could totally imagine a world where basically the data team's responsibility is to ensure that the model has the right context, that it's endorsed the right data sets, that they've made sure the tables make sense, that they've seeded the right context for the workspaces, and their responsibility no longer becomes building all these sophisticated dashboards. That data can be done on the fly by an agent. I think there's a real world where that happens.
Paul talked about deploying AI across thousands of real-world locations. What impressed you most about that?
I think the scale of it is the biggest thing, right?
The scale.
I think growing from the way they did in 2018, starting back in Venice, to where they are now across 1,000 locations, the way they acquired a lot of different parking lots, the way they kind of grew themselves both in a physical real estate sense and a sense of how do you implement technology to scale effectively to create a really strong, it just works model. Yeah, and you saw that graph Paul showed earlier about how many lines of code have grown since September of last year to now, and it's a very almost straight line up.
Yeah.
I think that, while it's in and of itself, allows you to grow features really fast, and it really allows you to showcase and build quickly in your company. The flip side is that you have to be really, really strict about your quality control. The old adage is that it's twice as hard to read code as it is to write code. And with AI-generated code, you're spending a lot more time trying to understand what the agent is delivering to you instead of actually writing and building a mental model. So how do you focus on balancing both sides of that coin, where your engineers can actually look at the code, understand what's happening in all layers, integrate and scale themselves, while also generating massive amounts of code to actually scale volume applications?
Would you want your car tracked if it meant never paying for a ticket again?
And I kind of grew up in the space of privacy is everything, right? When the EFF was a big thing, when we had, I forget the bill that went around about open internets. I am very high on my own privacy, but as time goes on, you kind of realize that nothing we truly do is private. And something like a license plate, yes, it's a little sketch, but you think about how many toll cameras are out there, how many different cameras are. It already exists. They get tracked everywhere. Yeah. So having a private company take control of, or having ideas of where you're parking and where you're doing, they might sell that data somewhere else. They might not. But at the end of the day, to me, it's not a big enough thing to make a stink about.